right, so based on what's given here, if I'm finding two numbers whose difference is 8, it's always nice on these problems to create an equation that connects the variables together that represent the information you're looking for, and they connect to an actual value. So if we're talking about two numbers whose difference is 8, if I pick two numbers, say x and y, a difference means I'm subtracting. Well, I could say, assuming x might be the larger number here, x minus y would equal 8. That allows me a way to set up some variables to represent the information I'm looking for, and connect it to an actual value. Now in the end here, we're looking for a product between those two numbers, which is a minimum. So that's the thing about these problems. You're trying to create functions that connect to either minimum ideas or maximum ideas. So once you set up an equation, I'd encourage you to set up a function, so maybe f of x for my function, that relates to the idea for the minimum or the maximum. In this case, it's a minimum, and we're talking about a product of the two numbers. So if my two numbers are x and y, and we're talking about a product, well, just take x times y. Now, the trick is setting up a function we can play with. And the thing about functions is we're used to seeing those in terms of one variable. So right now I've got the two variables to work with. It'd be real nice if everything was in terms of x, because that's just how we're used to seeing them. So what you could do is take your other equation, solve for the variable you're looking to replace. So over here I'm going to solve for y. If I solve for y, subtract x over maybe, divide by that -1. Dividing by that -1 is just going to change all the signs, right? So it's a -8, it's a positive x. I could just say x minus 8. We're going to take this x minus 8 now, plug it in over here to the function so that everything's in terms of one variable. When we plug in, we've got f of x equal to x times x minus 8. So if we distribute that x through, we've got x squared minus 8x. And now we have a function we can play with. Once we get to this point where we have our function, well, we just fall back here on the things we've been doing recently. We take our derivative. We know derivatives tell us something about where the function goes up, where it goes down, so that's how we make these connections to min and max ideas. When you take a derivative here, pretty straightforward, get 2x minus 8. And then if you think about what you do with those derivatives, usually we find critical numbers from here. In the whole grand scheme of things, when you're talking about a min and a max, what's nice on these problems is you only have to look at where the derivative equals 0. The does not exist side doesn't apply here, because this is an application. So where the derivative equals 0, derivative was 2x minus 8, set equal to 0 and solve, x is going to be 4, right? So we're trying to find two numbers whose difference is 8, whose product is a minimum. Looks like we found one of those numbers, right? X and y represented those numbers, so x we found to be 4. To figure out what y is, now let's see, go back to what y equals. Right? Y is x minus 8. So if I plug in here knowing x is 4, 4 minus 8 is -4. That other number I'm looking for is just -4. I've got my two numbers. So if we're finding a point on this curve that is the closest to the ordered pair 1, 5, what closest means is we're talking about a minimum distance here. So that's where our whole relative min, relative max factors in. And if we're looking for a point, well, if it's going to be a point on this curve, we could set up an arbitrary point. We could set up a point where All right, in the end here, it'd be nice to figure out what the x value is, because that's usually what we do. So let the x value at the point just be x. But then once we know what that x value is, because we know it's on the curve y equals x squared, we plug in, you'd be squaring that x, so your y value would just be x squared, right? So I'm comparing a distance, that's a minimum distance between this arbitrary point and this point 1, 5. So if I'm just comparing distances here, let's plug into the distance formula. D is going to equal, it'd be the square root of, got your difference in your x's, so if I go, say, from arbitrary point to given point, the x minus 1 is a quantity squared, plus difference in the y's going from arbitrary point to given point, the x squared minus 5 as a quantity squared. Let's go ahead and do some simplifying under here. Let's expand these out. Distance is going to equal square root of. Take this first binomial, expand it out. You got x minus 1 times x minus 1. You get x squared minus 2x plus 1. Just foiling things out, right, if needed. You're going to add on this binomial over here squared. So x squared minus 5 times x squared minus 5 would be x to the fourth. Be minus 10x squared plus 25. Let's put together what I can here. Let's see. Going in order, start with my highest power of x. I've got x to the fourth. Then we got some x squared. Looks like we got minus 9x squared here. X's, we've just got what, a 2x, minus 2x. And the constants, you got a 1 and a 25. So we've got our function to play with. We've made it all official now. We've got d of x representing the distance. At this point, we can take the derivative. So d prime of x equals, got a chain rule in play here, so bring down the 1/2. Got the quantity of x to the fourth minus 9x squared minus 2x plus 26. Inside parentheses, subtract 1 away from the power, so negative 1/2 there. Tack on the derivative of the inside, which is 4x cubed minus 18x minus 2. All right, everything is lumped together through multiplication. We can clean this up a little bit, create a big fraction. Denominator in that fraction would have a 2 in it. We have that quantity that was raised to negative 1/2 bumped downstairs. That changes everything to a positive 1/2 as far as the power is concerned. Leftovers on top, you got a 1 and you got the 4x cubed minus 18x minus 2. Okay, so at this stage, because it's an application, we're going to look to see where the derivative equals 0. To see where the derivative equals 0, all we got to do is take that numerator, set that equal to 0 and solve. Now, in reviewing strategies to solve something like that, that's not a quadratic. Factoring is not going to be involved. So this is where we basically got to graph this out, right? Let y equal 4x cubed minus 18x minus 2, graph it out, see where it crosses the x-axis, get the zeros. Now, we've discussed that strategy before. We're supposed to understand how to do that. If we do that correctly, it turns out that x equals 3 things. We've got negative 2.06, apparently it crosses the x-axis there. Also crosses at negative 0.11, and it crosses at 2.17. Now, This x value is supposed to represent the x value at the point we're trying to find, which is the point that would be a minimum distance away from this guy right here, right? 1, 5. Now, we might want to do some graphing of the original curve to look at this, but if you try to make sense of it, you know, which of those x values makes sense to be closest to 1, 5? 2.17, right? So we'll take these out. They are solutions to that equation, but as far as what we're concerned about here, finding our x for that point, our x for that point would have to be 2.17. Figure out the y value. Well, we know what x is now. We know this is 2.17. Plug in, take 2.17 and square it. So 2.17 squared is 4.71. There's our point. That's a minimum distance on that curve from 1, 5.